Okay, folks, this is Math Model Semester 2, Study 2.41, Transformations. Now, before we jump straight into the lesson, what I want to talk about is a coordinate graph where you have an x and a y axis, vertical being the y axis, horizontal being the x axis. Because in this lesson, we're going to talk about transformations, and we're going to talk about transformations as it relates to different figures, triangles, squares, rectangles, and different things like that. And so it's going to be very important that we understand how to label points. So one of the first things I want to cover, let's say I have an arbitrary point somewhere over here. I'm going to give it the coordinate 4, 4. Okay, in the first quadrant, which this quadrant here is the first quadrant, x and y is going to be positive. If I was to move over here to my second quadrant, then x is going to be negative because it's on the left of the origin, the left side here. So x will be negative. Say I have a point that's here. That point could be negative 2, 2. Okay, where x is negative and y is positive. And you can keep on going, but basically on the coordinate graph you got quadrants 1, 2, 3, and 4, and it's important to know in which quadrant which value is positive and which value is negative. So just as a review, I'm gonna let you know in the first quadrant x and y is positive. Over here x is negative, y is positive. Down in quadrant 3, x is still negative, but y is also negative. And over here, x is positive and y is going to be your negative value. Okay, we're going to use those things to represent, well, those rules that you have in yellow are going to be used a lot in this lesson. So I just wanted to make sure we had a great understanding and a good foundation to get started. Okay, folks, so transformations in summary, number 1 says fill in each blank. So translations, which is a slide, reflections, which is a flip, and rotations, a spin, are all rigid motions. The reason why they call rigid motions is because the shape doesn't change at all. It's just moved around in some kind of way. Okay, dilations and stretches are not considered rigid motions. And to be honest, I really don't like that they say in stretches. So I'm going to just go ahead on and delete this line right here. It's really just about dilations, because dilations is either an enlargement or a reduction of a certain object. Okay, so in practice number 2, it says complete the table below to show image coordinates for different counterclockwise rotations about the origin. So what I did, I went ahead and X'd out A, B in parentheses, because that's really not traditionally how we would write coordinates. So I'm gonna just scratch that all the way out. Normally we write them with X and Y, so I wanted to keep it in that format. So I'm going to show you in a second what all of those rotations would look like, and don't worry, we'll get a little practice in a minute. Okay, so what you see is just what happens to the pre-image, which is your first image, after it goes through a rotation of let's say 90 degrees. I'm gonna start focusing here on 90 degrees. Notice right here with the rule, whatever value you have for x and y, those negative signs that you see just mean that the sign changed. So if it's positive, it'll become negative, and if it's negative, it'll become positive. Now, if this sounds strange, don't worry about it. We're gonna practice in a little bit. Okay, number 3 says complete the table below to show the image coordinates for reflections across the x and y axis. Just remember that a reflection is a flip. So when you see the word reflection, just think of flip. And in the word reflection, the 2 letters FL is already there. When you see the word rotation, I'm sorry I forgot to mention, when you see rotations, just think of a spin. That word right there. Rotation is a spin, and reflections is just going to be a flip. Now, once again, they went ahead with the AB thing, and I really don't like it, so I'm going to go ahead and cross those out and put what we are used to seeing, where we would have X and Y here and X and Y there. That would be how we write points. Remember, X always comes before Y, and this will be our values for our pre-image. So our pre-image is just always going to be our first image, and our image is going to be the final. Whoops. Final. Okay, so for a reflection across the x-axis, pause. I just wanted to show you kind of what it looks like, even though we're gonna get practice in a minute. In a minute, a reflection across the x-axis. This is my x-axis going left to right. So if I have a point that's here, that's my pre-image. The final image is gonna be right there. So what happens is the x value stays the same, but the y values change. And here's what that looked like in notation. Meaning if the blue dot represents my pre-image and the green one represents my final image, then the y value change, it changes how high it is up, but it doesn't go left to right. Now, try to change up the colors a little bit, but if I do a reflection across the y-axis, highlighted in orange, and let's say I take that same green dot and I flip it across the y-axis, it's going to become somewhere around there. Okay, so what you notice from the green dot, which is my new pre-image, to my final image, the orange dot, what you see is that the x value change. So let's write that in notation. And what I hope you notice is that even though we're saying that the value change, it can change from positive to negative or from negative to positive. That negative in front of y, which you see when you flip across the y-axis, across the x-axis, that negative right there just means we change the sign. And the same thing is true for this negative here. So if it's negative, it becomes positive, and if it's positive, it becomes negative. Gonna look like I skipped around a little bit, but practice 4, the problem isn't on the page, so I wanted to make sure we talk about it when you see it. So 4 says rotate triangle ABC 90 degrees counterclockwise about the origin, label the coordinates of the image. Now here's the thing. You see all these words right here? Counterclockwise, about the origin. Every single rotation you've been doing is going to be counterclockwise about the origin. I haven't seen a problem where they give you one that's from a different point or it's actually clockwise. And anytime you see it in notation form, know that it is always going to be counterclockwise for the purpose of our lesson. Okay, so what I went ahead and did was wrote down the coordinates for every single point that we have given on that triangle ABC. So what you should do every single time when you're trying to figure out what the transformation look like, if you're having a hard time with doing it on the graph, then go ahead and write down every single point that you have that's listed. So when you do rotate it 90 degrees, you can tell a difference. Now let's think about the rule. When you rotate something 90 degrees, the rule says it goes from your pre-image, which is at XY. That's all your points you have here. And what happens is when it changes, the Y value becomes the X value and the sign changes, and the X value stays exactly the same. So that's what happens after a rotation. So what I like to do is just go ahead and label A, B, and C, and I put a little apostrophe. That apostrophe means that's my image. That means this happens after the rotation, and I make my parenthesis marks with my commas because I'm going to be writing points. So since the X values, which are all right here, are going to become Y values, I'm just going to list all of those right here. 2, 3, 4. And then since the Y values, which are here, the signs is going to change, I will list them here. -3, -5, -3. Because once again, that sign change that's represented by this little negative sign in front just means change the sign. So if all of those was negative, they become positive. If they was positive, they become negative, which is what just happened from here to here. Okay, so now I'm going to draw my figure. Okay, so now I have my figure, it's labeled, and I just connect my dots. So that's what a rotation looks like, 90 degrees counterclockwise. Remember, counterclockwise just mean if this is the way that the clock hand goes, then counterclockwise mean we're rotating this way in orange. All right, let's do some more practice. Okay, so our next assignment, or our next question, asks us to reflect ABCD, that trapezoid, across the x-axis, and we're going to label the coordinates of the image. So the first thing I want to do is label the coordinates of my pre-image, which is given. So with the reflection being across the x-axis and the x-axis run horizontally, we would just flip everything across that red line. So one way to look at it is that the point A is at 1, 1. And since it's 1 point above, it's not going to go left or right. So it's going to be 1 point below that line. So it's going to be A prime should be at 1, -1. So that should be the location for A prime. Okay, I'll be back in a second. I did want to say from the rule that if you flip it across the x-axis, that's perfectly fine. If you like rules better, it starts out with xy. That's our pre-image, all of our values there. But when we flip it across the x-axis, the x value will stay the same and the y value will change. So that's what that should look like. So every single x value will be exactly the same, and the y value, the sign is going to change. So you got 1, 2, 6, 7. So it'll be 1, 2, 6, 7. But the y value will go from 4 to -4, and d will go from 1 to -1. All right. So I went ahead and just plotted all my points. So now all I'm going to do is just connect the lines. So now you can see what it looks like if you were to reflect that triangle ABCD across the x-axis. And you have your rule, which is right there. Okie dokie. Okay, this next part, practice 5, says making predictions and summarizing. So A says describe what happens when you reflect ABCD across the x-axis and then reflect it back across the x-axis. So if the x-axis is highlighted in blue and you take that rectangle and flip it across the x-axis and then flip it right back, what you should have is just the same image. It's just going to map right on top of itself. So it'll the image maps onto the pre-image. And that's it, just written for you right there. You get the same image, the image maps onto the pre-image. Okay, so B says describe what happens when you reflect ABCD across the y-axis and then translate it 4 units down. What's going to happen is that the image and the pre-image are going to be congruent. You're just going to have a figure that gets reflected across the y-axis. So if I was to show you, instead of the ABCD being here, it's going to be over here, so reflected across the y-axis, and then translated 4 units down. So it'll be shifted down by 4 units. So it should be somewhere in this general space here. Okay. Also known, these are all rigid motions. Just to bring up that vocabulary word, because when you reflect across the y-axis or translate or once again rotate, the image is going to stay exactly the same. The next one, C, says describe 2 different ways to obtain the image below. So what it's telling you is that this is not the first image. This is the final image. This is what happens after. So what I'm going to say is that it could be 2 reflections. One of the reflections could be across the y-axis followed by one across the x-axis, or it could be the opposite, a reflection in the x-axis followed by the y-axis. But those 2 should get you the exact same pre-image. The other way would be to rotate the pre-image 180 degrees counterclockwise. And there you have your 2 ways that you could obtain that final or the final image of that trapezoid. In summary, it says in coordinate notation, a horizontal translation by a unit has this rule. So the first thing that I want you to know is when you see the word translation, know that all we talking about, SL, is a slide. Okay, and once again I'm going to draw my y and x axis. I hope this helps. But if we move on the horizontal side, that's going to be from left to right, then the y value is going to stay exactly the same. So we're going to write it in parentheses. Okay, here we go. So we'll have our pre-image, which is xy. And when we do our horizontal translation or horizontal slide, what you'll notice is that the y value, the y-axis, was totally unchanged. And the x value, we can either add or subtract, you may see, but in this lesson they just chose to go with positive because it's the same. You can add a positive number or you can add a negative number. Okay, so then we have in coordinate notation, a vertical translation by B units has this rule. So what we're talking about is if I move something up or down on this orange line here. So what's going to happen is that you'll start with your same x and y coordinates for some point. And what's going to happen, notice with the orange line, the x value stayed exactly the same. We didn't move left or right. But when we move vertically with the y value, we can either add or subtract b, some value. And we're going to put it in practice in just a moment. So number 7 says, how can you find the coordinates when xy is rotated counterclockwise 90 degrees? Well, what you got to know is in the beginning, when we start off with our pre-image, we have some point that's at xy. But when we rotate it or spin it 90 degrees counterclockwise, what's going to happen is that the y value is going to change with the x value, and we're going to change the sign, and the x value is going to stay just the same. So what they're saying is that you need to multiply the y value by -1, then switch the x and y coordinates. That's the best I can get it to make it fit. So then it says, how can you find the coordinates of xy? Find the coordinates when xy is rotated clockwise. So think about working backwards. So when you start out with your original point, but instead you're going to multiply the x value by -1 and switch the x and then switch the x and y value. Sorry, I'm writing this wrong. So y would be here, but you would multiply the x value by -1. You won't let me move the words around, but that says multiply the x coordinate by -1, then switch the x and y value. So drawing inferences, this is number 8. It says, what happens to xy when it is rotated 180 degrees? So you can go back to your chart in the beginning, or if you want it, you can just take my word for it. So what happens with xy, your pre-image, when it's rotated 180 degrees, both the x value change and the y value change. So you change the sign on both the x and the y coordinate. Summarizing, number 9 says, what are the rules for the following reflection? A reflection across the y-axis. Across the x-axis. So here we go. Whoops. Let me get a pen. So across, this is y, this is x. When we flip it across the x-axis, what happens is that the x value stays the same and the y value changes. Now, when we reflect across the y-axis, which is here, what happens is the y value is going to stay the same. It's not going to go up or down, but the x value is going to change. And when we reflect across the line where y is equal to x, and I just want to show you real quickly what that line looks like. You have your regular graph where you have y and x, but wherever y equals x, if y is 0, x is 0. If y is -1, x is -1. Sorry, this should have went straight through the origin. My drawing's a little bit off, but that's okay. But that's the line where y is equal to a negative x. So what happens then, you'll see is that you'll have your pre-image, xy, and when it goes across that line, only thing that changes is just the position of the letters. You switch the x and y coordinate. Now, if we were to go across the line where y is equal to a negative x, that's this line right here in red. So this is the line y equals a negative x, and this is the line where y equals x. Okay, what's going to happen then is that you'll start with your same original x and y, but when it goes across that line, two things are going to happen. The position of the coordinates are going to change, and also the sign. Okay, so y and x will change signs and positions. So if it's positive, it'll be negative, and if it's negative, it'll be positive. So in summary, it says a dilation with a scale factor of k and the origin as the center of the dilation can be described by this rule. So we'll talk about it a little bit more in detail. We'll have our initial points, which is x, y. But what you'll notice is that they'll have a small letter k. That k is going to represent the scale factor. What happens is, whatever your scale factor is, it's going to be multiplied by the x value and also multiplied by the y value. Okay, so What you need to know is that a dilation uses a scale factor of k, which I just said. When k is greater than 0 but less than 1, the dilation is going to be a reduction. And when the scale factor is greater than 1, the dilation is going to be an enlargement. So here's what this can look like in practice. Let's say we have a point, and that point is at 1, 1. Okay, that's my pre-image. Now let's say I want to enlarge it by a scale factor of 3. Well, what's going to happen is you'll multiply 3 times 1 and 3 times 1, and then so your new point after that enlargement would just be 3, 3. Okay, because you multiply both the x and the y value by 3. Now let's say I take that same, and I'm going to put a prime right there because that's my final image. Let's say I take that same pre-image point and I want it to be half the size. Okay, so it's going to get smaller. Well, what's going to happen is that we'll have 1 times a half, comma, 1 times a half. And anything times 1 is just itself. So my new point is going to be half the size. So it's going to be half, comma, half. And that would be the coordinates of my point. Or it could be 0.5, 0.5 if you want to do fractions. Do decimals. Okay, folks, and this concludes our lesson. Remember, I love you very much. Do your best. I'm encourage you to check out the checkup problems. If you have any questions, that's why I'm here to help you. I hope you have a great day and a good night. Bye.